Hey there, students. So here's what I'm looking at today. First of all, I want to be able to finally get at looking at the entire sine function. So we know, for example, that like sine, oh my gosh, the handwriting is bad. Sine of an angle is in a right triangle opposite over the hypotenuse. But that means we have an input of an angle and we have an output of a ratio. Well, inputs and outputs feel to me a lot like x values and y values. And so that's what I really want to look at today. Like this first graph would be y equals sine of theta or sine of x, whichever, it's normal to use theta, but in a function it's normal to use x. So yeah, sine of theta or sine of x either way. And then the y value we get out would be the ratio that it's equal to. So the first thing I want you to do is go ahead and go to your calculator. I guess I'll pull up my calculator. If my computer wants to do anything, come on. Cool, and I would just literally be going like 0. Oh, and I should have looked at directions. Graphing y equals sine and y equals cosine. Use your calculator to fill in the values of the trig function in the table. So that's where I'm going first. I'm going to use my calculator to do 0 trig functions. Sine of 0 is 0. Okay, so sine of 0 is 0. Then 30 sine. I see that's 0.5. So I go 0.5. Then 45, so I'll do a couple more. 45 trig sine, I get 0.7071. I should have given you, I'm realizing now, a little more space. So sorry, 0.7071. And then do the sine of 60 degrees, the sine of 90 degrees, sine of 135, 180, 225, 270, 360. So then you'll have this table filled out. And next, plot those points. So next, okay, let's go ahead and plot these points. We've got 0, 0, easy. Then 30.5, well, okay, 15, 30, 45, so 30, 0.5 is right in there. 45.7071, so that's 45.6, 0.8, so 0.7 is like halfway between, 0.7071 is like slightly higher than halfway there. And then 60 degrees, we'll have another angle, so 45, 60 is going to be here, we'll have another angle, and then 90, another angle, and whatever. Like plot those points, whatever you get, all through here. And then when you plotted those points, draw a smooth curve that makes sense. So you've got your points, go ahead and draw a smooth curve. These look like they're linear, but you'll see when you have more points, they're not quite linear. These are like linear-ish, but there's a slight curvature like downwards. And then whatever, show me what the rest of this graph does. And then same thing, cosine, fill in this using your calculator, plot those points, and go ahead and graph it. Last one, I want you to check out tangent, and tangent is weird. So it's clear when I read the directions that there's something weird's gonna happen. Use your calculator to fill in tangent values, then plot the points or plot discontinuities as vertical asymptotes and connect the graph. Okay, so let's get out my calculator and check this out. So we've got -90. So I have to go 90, make it negative, and then trig tangent. Invalid input. That means this -90 does not exist. That's not a theta. That is a null set. It does not exist. So then I'd go 60, negative, trig tangent. I get -1.73, -1.73. Wow, my handwriting is really extra bad. And then -45 trig tangent, -1. So great, we'll get values like that going through your tangent function, and then we'll plot those. In the directions I said, plot discontinuities like this one as vertical asymptotes. So at -90, we've got this vertical asymptote action going. We've seen that before, so that's nice. And then -60, -1.73 is like somewhere in here. Maybe -45, -1. Great. And then you'll get values. Go ahead and plot your tangent function. Once you have a graph of those three functions, then I want you to watch the second video. So this first one is just to get you started on graphing the functions. In the next one, I'll show you what you should have seen and then how we're going to use it and where we're going next. So yeah, do this piece and then check out the second video. Talk to you soon.